Today we are going to learn how to find largest difference in the given array. Suppose we need to find out largest difference in this given array. We have this array, and one condition is also given: larger number should appear after smaller number. So in this case, we have larger number like 8. So and we have minimum number 3. So we have 3 here and we have 8 here, so difference will be 5, and we have a smaller number here 1 and larger number 7, so difference will be 6. So largest difference will be here 6. Okay, so what we can do, we can run a for loop here, and I equal to 0 to I less than n is the length of the array. So while running for loop, we can find out largest sum. Suppose given array is two number array like 10 and 3. So for this, largest difference will be 0 because 3 is a smaller number than 10, and see the condition, larger number should appear after a smaller number. So uh, after 10 we don't have any larger number, so in this case it should be 0. And suppose given array was this one, 10, 13. So 13 is a larger number and it is appearing after a smaller number. Smaller number is 10. So in this case, larger difference should be 3 only. Okay, cool. So how we can find out difference? We can find out difference like this. Difference equal to array of I minus minimum number. Okay. So like in this case, minimum number was 10. Okay. So we have difference as 3. For this case, we will have array of I as 3 and we don't have minimum number which is lesser than 3. So in this case we will have a default value as 0. So initially we will have difference as 0 only. So and suppose given array was this one, 6. Okay, so now we will be here 6. So first we need to find out minimum number in this sub array 10 and 3. So like sub array which is appearing before number 6. So first we need to find out minimum number in this sub array. So minimum number will be 3. By applying for loop we can find out minimum number. So like we can have initially we can have minimum variable. Initially it will be array of I, array of 0. So in this case it will be 10. Initially it will be 10, and we can apply a for loop here for j equal to 0 to j less than I. Okay, and we can update our minimum number like if minimum is greater than array of j, then we can update our minimum number, minimum equal to array of j. So by running this inside for loop with j index, we can have our minimum number. So here we will get our current difference. So in this case we will have minimum number is 3. See, with this for loop at line number 12 it will give minimum number as 3 only. So okay, we can traverse also. So initially j will be here and we will have our minimum number as 10 initially. Then we will increase our j index. So j will be here and j should be less than I. So j is less than I. So now we have array of j as 3 and minimum as 10. So 10 greater than 3, it is true. 10 greater than 3. So we will update our minimum number. So minimum number will become 3. Okay. So after running this for loop, we will have minimum as 3. So at line number 17 we will have difference. So we will have array of I is 6 minus 3. So we will have our difference as 3. Okay, and suppose given array was this one, we have 4 also in the array. So we have done calculation till 6 and I here. We will increase our index, we will have I here. So now first we need to find out minimum number in this sub-array which is appearing before 4. So for this sub-array we will get minimum number as 3 only. After, so first j will be here. So we will have minimum as 10. Then we can have minimum number as equal to array of 0. So initially it will be 10. Initially minimum will be 10. Then we will increase our index. We will have arrow of j will be 3. So 3 is lesser than 10. Then we will update our minimum. So minimum will become 3. Now we will increase our j index. So arrow of j will be, we will have minimum as 3 and arrow of j will be 6. So 6 is not lesser than 3. So this condition will false and we won't update our minimum number. Cool. And I will be here only. If we increase our index, then j will become equal to the ith index. Then this condition will false. J less than I. Okay. Then we will terminate our loop and at line number 18 we will find out difference. So array of I is right now array of I is 4. Okay, and we have our minimum number as 3. So difference will be, current difference will be 1, and we had our previous difference as 3. So now this difference will be updated as 1. So now we need to store our previous difference in some other variable, because at line number 18 it will be updated by 1, but we know maximum difference will be 3 in this given array at line number 7. Maximum difference will be 6 and 3. If we subtract 3 from 6, then it will be 3 only. So we can have this condition: if difference is greater than maximum difference, then we will update our maximum difference equal to current difference. Okay, so we can introduce a new variable to save existing maximum difference. So now we will again apply for loop. Okay, we will again apply for loop. Cool. So initially I will be here. So we will have minimum as 10. So we will have difference as 0. So arrow of I will be 10 minus minimum. So here see line number 12, minimum will be 10 only. So we will have our difference as 0. So we will have this variable here, maximum difference, maximum difference. So initially it will also 0, it will be 0 initially. So we will have this condition here. So we will have 0 greater than 0. So our maximum difference will be 0 only. Okay, this condition will be false. And now we will increase our index I. So for this index, arrow of I will be 3, and we will have minimum as 10. So our j will be here only, and j is less than I. This condition will be true. So we will try to find out minimum number. So minimum number will be array of j, it will be 10 only. So right now we had minimum number as 10, so here it will be 10 greater than arrow of j. Arrow of j will be arrow of 0. Arrow of 0 will be 10 only, so this condition will also false. So we will have our minimum number as 10 only. See line number 14. Okay, so at line number 20 we will try to find out current difference. So current difference will be arrow of I. Arrow of I will be 3, and minimum difference, minimum number will be 10, so it will be -7. So we have this condition, difference, current difference is -7. If -7 greater than 0, maximum difference, we had maximum difference as 0. So then we will update our maximum difference. So this condition will be false only. So we won't update our maximum difference. Maximum difference will be 0 only. Now we will increase our I. So I will be here. So now again we will at line number 15 we will apply this inside for loop, and we will try to find out minimum number. So initially we will have minimum number as 0, then this condition will be false, then minimum number will be 10. Now we will increase our j index. So right now we have arrow of j as 3, and we have minimum number as 10, and array of j will be here 3. So this condition will be true right now. So we will update our minimum number, it will become 3. If we increase our index, then j will become equal to I. So this condition will false, j less than I. Okay, so now we will terminate this 15 number for loop. Now we will come here, we will have array of I as 6, and minimum will be 3. So we will have our difference as 3, and we have this condition, our current difference is 3 greater than maximum difference. Maximum difference was 0, so this condition will be true. So we will update our maximum difference, it will become 3 only. Now we will increase our I index, so it will come to 4. And again for this for loop, line number 15 we will start j index from 0. So earlier we had minimum number as 3. Earlier minimum number will be, say line number 14, it will be 10. Then we will j will come here, we will update our minimum number as 3. Now again j will come here, so we will have our minimum number as 3. See here line number 17, we had our minimum as number as 3. So 3 greater than 6, so this condition will be false. So we won't update our minimum number will be 6 only. Now if we will increase our j index, then j will become equal to the I, and this condition will become false, j less than I. So we will terminate this inside for loop, and we will come line number 20, and right now array of I will be 4, and we had our minimum number as 3, so it will become 1. So right now we have our current difference as 1, and our maximum difference as 3. So this condition will be false. So still we have, see, our maximum difference as 3. So we have maintained our maximum difference by using this variable. Next step. Okay, so now suppose we have another number in this given array 8. Now I will be here at 8, and again we will start j index from first index. Okay, see line number 15, j equal to 0. So again we will try to find out minimum number in this sub array, okay, which is appearing before this given number 8. So minimum will be 3 only. By applying for this for loop, we can find out minimum number. So it will be 3 only. So array of I will be 8. Okay, and minimum will be 3. So difference will become 5. So right now we have our current difference as 5 and maximum difference 3. So this condition will be true. Now we will update our maximum difference. So it will become 5. Now suppose we have another number at 1. Now we will increase our ith index. So we will start jth index from 0. See line number 15. So it will find out minimum number in this sub-array. See line number 7. So minimum number will be 3 only. So now right now we will have our arrow of I as 1, minimum number is 3, so it will be minus 2. So our maximum difference was 5 and our current difference is minus 2. So this condition will be false. So we won't update our maximum difference. Okay. Now suppose we have another number 7. So I will be here. Okay. So initially line number 14, minimum number will be 10. And we will start jth index from 0. See line number 15. We will start from here and we will try to find out minimum number in this sub array which is appearing before 7. So I think minimum will be 1. See, because we had our minimum number as 3 till this index, till this j index. Okay. And if we increase our j index, then we will be at 1. Now we need to compare minimum as 3 and array of j will be 1. So 3 is greater than 1, it is true. So we will update our minimum. So it will become 1. So we will have array of I as 7 and minimum number as 1. So it will become 6. Difference will become 6. See, array of I will be 7 and minimum number in this sub array will be 1 only. Okay, it will become 6. Now we have current difference as 6 and our maximum difference was 5. So this condition will become true. So we will update our maximum difference. It will be 6. Okay. Now we will increase our I index, then it will become greater. It will become equal to n. Then this condition will become false. I less than n. Now we will terminate our for loop and here we can print maximum difference. Okay. So for this approach we have time complexity as order of n square, because see, when we are running line number 13 one for loop and at line number 15 another for loop j. So for each element, like I is here, suppose initially I will be here, so we won't run this just inside for loop. Okay, now I will be here, so we will run for loop one time. We will run j for loop and we will visit this number 10. Now I will be here, so we will again visit 10 and 3 number, and I will be here, then again we will visit 10 3 6, because we are starting our j index from 0. Okay, then I will be here, again we will start visiting this sub array from 10 to 4, 10 3 6 4. Now again we will increase our I, then again we will visit 3 10 3 6 4 8. Okay, then again we will increase our I index, then again we will visit 10 3 6 4 8 1. So for each iteration of ith index we are visiting this sub array. Okay, this sub array which is appearing before ith index. So there in the array there will be multiple numbers which are visited more than more than 2 times. Okay, so uh, the subarray which is appearing before ith index will be visited many times. Okay, so we have our time complexity as order of n square. So what we need to optimize this solution. So what we can do, if we remove our this for loop, then we will have our time complexity as order of n square, because we will visit given array with ith index only, and with ith index we are visiting given numbers only once. We will visit 10 only one time, 3 one time, 6 one time, 4 8 1 7 only one time. Okay, with ith index we will traverse through the array only once, so we will have our time complexity is order of n only. So how we can eliminate this for loop? So we can have one condition here instead of this for loop. So initially, like line number 1, we will have arrow 0 as minimum number, it will be 10. Suppose I was here. So for this one we will have minimum number as 3. Okay, so we need to update minimum number after finding maximum difference. So for this case minimum number will be 3 and current number will be 8. Array of I will be 8 only. So we will have difference as 5. 8 minus 3, it will be 5. Then we can do other steps. So we will have, and for this condition suppose I was here. So we will have our minimum number as 3 for this case. So we need to update our minimum number after doing this process. Okay, if we update our minimum number here only, if array of I less than minimum number, okay, then we need to update our minimum number equal to array of I. So what will happen here, we will have our minimum number as 1, but for this index ith index we should have minimum number as 3, because sub-array which is appearing before 1 have minimum number is 3. Okay, in this sub-array minimum number will be 3. So for so like then at line number 18 we will have difference array of I minus minimum number. So in this case array of I will be 1 only and minimum number will also 1, so difference will become 0. Okay, 1 minus 1, it will be 0. Okay, so that's why we should have this condition after processing these steps, line number 17 18 19 20. Okay, cool. So like first we will process these things. So in this case our minimum number will be 3, array of I will be 1, so 1 minus 3, it will be minus 2, so it will work perfectly. And here we will have our array of I as 1 less than 3, minimum will be 3, so we will update our minimum number, it will become 1. Cool. Okay, so what other optimization? So for this approach we are traversing each number in the given array only once, so time complexity will be order of n only, and space complexity will be order of n, because we are not introducing any other new array. Okay, so only we are using these variables like diff, maximum difference, minimum variable. And what else we can do, we can eliminate this difference variable, like instead of this difference variable we can have direct this thing. Okay, array of I minus minimum. Okay, in the parenthesis I will put, if array of I minus minimum greater than maximum difference, then we will update our maximum difference, so we can eliminate this diff variable. Okay, so because more variables we will have, our program will become more complex to understand. Okay, so we have only minimum variable and maximum difference variable, and current difference we can find out through this statement, array of I minus minimum number. Cool. So now for this given problem we can have any input. For this array we can have like input arrays like line number 9, 10, 11, 12. For in this case minimum number will be like for this sub array minimum will be 2, so difference will be 1 till here. Difference will, largest difference will be 1. Okay, if we go I here, we will, if we will increment I, so largest difference will become 8. We increase our ith index, then minimum number will be 2 in this sub array, so difference will be 4 only. So we will we want to update our maximum difference. Again we will have 4 here and minimum number will be 2, so difference will be 4 minus 2. So we want to update our maximum difference. See line number 11. Again we will increase our index, so we will have 8 here and minimum number will be 2 only in this sub array, so difference will be 6. So we want to update our this maximum difference. Now we will increase our ith index, so for this sub array minimum number will be 2 only, and current difference will be -1, and -1 is lesser than 8, so we won't update our maximum difference. So output will be maximum difference, which is 8. For this given array we will have 2 here and we will have, if I will be here then maximum difference will be 2, then we will increase this index, then minimum number in this sub array will be 7, so we will have difference as -2. Now we will increase our index, then we will have our difference as current number minus minimum number. Current number is 6, so we need to find out minimum number in this sub array, so it will be 5. Minimum number will be 5, so we will have difference as 1. We will have difference as 1. Okay, now again we will increase our index, so we need to find out minimum number which is lesser than 3. So we have minimum number as 5 in this sub array, so difference will be -2. Okay, difference will be -2, so -2 is lesser than 2, so we won't update our maximum difference. Now we will be here, and minimum number in this sub array will be 3, so minimum difference will be -1, and maximum difference is 2. So our for this sub array, for this array maximum difference will be 2, 9 and 7. Suppose given array is sorted, we have this given array, so for sorted array always the largest difference will be largest number minus first number, so it will be 3. 4 minus 1, 4 minus 1. For sorted array which is sorted in descending order, largest difference will be 0, because none number will appear, none larger number will appear after smaller number, because all largest number will appear before smaller numbers. See 1 is a smaller number, so all larger number will appear before 1. 2 is a smaller number, all larger number will appear before 2. 3 is a smaller number, all larger number will appear before 3, 4. Okay, so now I am going to write C program for this given approach. Okay, so before writing C program I can comment these things. Okay, now I will start writing C program for this approach. Hash include standard input output dot h. Then we will have our main program. Then we will return our main method. We will return our we have main method as integer type, so we will return 0. So we have array length as n. For in this case it will be 1 2 3 4 5 6 7. Okay, it will be 7. And in this case we will have array given array as 7 equal to this one. Okay, and for traversing through the array we will have ith index. Okay, and we will have maximum difference variable. Initially it will be 0. Okay, we will run a for loop from I equal to 0. First it next to last index. Last index will be less than n, which is n minus 1. Okay, and we will have another variable which will be minimum variable. Initially it will be array of 0. Okay, so if array of I minus minimum number is greater than maximum difference, then we will update our maximum difference. Okay, now we will update our maximum difference. Then maximum difference will become current number minus minimum number, which means current difference. Okay, so we can update our minimum number also. If array of I is lesser than minimum number, then we will update our minimum number also. Okay, and after running this for loop, line number 13 to 21, we can print our maximum difference. So here we can print maximum difference. Now I will run this program and we will see the output. Okay, see, for this given array we will have maximum difference is 6. See, 1 and 7, it will be 6. Suppose we had 17, so maximum difference will be 16. See, 16. If we have suppose here we had 14, so maximum difference will be 14 minus 3, which is 11. So again I will run, it is 11. So this is a dynamic program. It will work with any given input array. So we have, for this program we will have time complexity is order of n and space complexity is order of 1. Okay, what I will do in video description, I will provide link to this source code. Okay, bye, thank you.